In this video, I want to take a look at trickier examples for quadratic inequalities. So we start with the first question here. We're asked to solve 2x squared minus 5x minus 3 is less than 0. So in this case, it's a little bit more complicated because the coefficient of x squared isn't just 1, but the method follows the exact same as we saw in the previous video. So we start by factorizing here. I'm going to factorize this into double brackets here. Because it's 2x squared, what that means then is at the front of one of these brackets, I'm going to have a 2x. At the front of the other bracket, I'll simply have x. Okay. So we need two numbers here. That times can be minus 3. So I could have positive 1 and minus 3, or I could have minus 1 and positive 3. It's up to you how you kind of solve or factorize this quadratic here. People have different methods for it, whether you do that by inspection or use a specific method. But in this case, what you should get here is 2x plus 1. And you should get x minus 3. Okay. So in this case, now what we need to do is identify the critical values. So from this bracket here, I'm going to get that x is equal to minus a half. So what you get here is 2x plus 1 is equal to 0. Subtract 1 off both sides. So that would be 2x equals minus 1. And divide both sides by 2 to get x equals minus a half. And then from this bracket here, we'd simply get x equals 3. Okay. So what we want to do now is draw a sketch of this quadratic. So if I quickly draw a sketch here. Remember, it doesn't need to be perfect, but just so we can see the quadratic that we're working with here. And it'll look, say, something like this. So from our critical values here, it cuts through at minus a half. Let's say that's there. And at positive 3. And let's say that's there. So it's going to look, say, something like this. Like so. So that's minus a half there. This is positive 3. It also cuts through the y-axis at minus 3. Okay. Now, where is this less than 0? So where is this below the x-axis? Well, if I do that in a different color then, let's do it in green. That would be below the x-axis here. So in this case then, our solution, we're going to be between minus a half and 3. So that would be a strict inequality as well, because the original inequality is strict. So in that case then, like we said, we're between minus a half and 3. Okay. And there we have it. So that's the solution there to question 1. Moving on to question 2 now, we're asked to solve 3x squared minus 13x minus 10 is greater than or equal to 0. So again, we start here by factorizing this quadratic. We're going to factorize this into double brackets. Like so. At the front of one of these brackets here, we'll simply get 3x. At the front of the other bracket, we'll get x. So again, it's up to you what method you use here to factorize this quadratic. What you should get here is 3x plus 2. In this bracket here, you should get x minus 5. So from here, I now need to identify the critical values. So for 3x plus 2, set that equal to 0. So 3x plus 2 equals 0. Subtract 2 off both sides. So that's 3x equals minus 2. And then finally divide both sides by 3. So what I get here then is x equals minus 2/3. Or minus 2 over 3. And for this bracket here, nice and straightforward, we simply get x equals 5. Okay. Once we have the critical values like we've got here then, we simply need to draw a sketch of this quadratic. If I draw a sketch here, that's my y-axis here. And this is my x-axis here. So we've got minus 2 over 3 here. That would be, say, there. And we've got positive 5. So what I'm going to do now is draw the sketch here. And it looks, say, something like this. Okay. Like I said, this is minus 2 over 3. That point there. And this point here is positive 5. Okay. We're now looking for where this quadratic here is greater than or equal to 0. So in other words, where is this above the x-axis? So here we have two regions. If I do this in orange here, we have everything to the right of positive 5 here, like so, and everything to the left of minus 2 over 3. So how do we present this here as a solution then to this quadratic inequality? Well, what we're going to get here then for question 2 is we get x is less than or equal to minus 2 over 3. So notice here that the inequality sign should also include the equals here, like we can see for our solution and for the original inequality. We've got x is less than or equal to minus 2 over 3 because we want values smaller than minus 2 over 3 or equal to minus 2 over 3. And we also have x is greater than or equal to 5. Okay, and there we have it. So that's the solution there to question 2. And finally then, if we move on to the last question here, or the last example then for trickier quadratic inequalities, what I want to do now is solve x squared plus 7x minus 30 is less than or equal to 10x minus 2. So where do we begin here? Well, what I want to do is make either the left-hand side or the right-hand side of this quadratic inequality 0. And the easiest side to work with here would be the right-hand side, so 10x minus 2. So if I just start by writing down this quadratic inequality here, we've got x squared plus 7x minus 30 is less than or equal to 10x minus 2. So like we said, the right hand side here is easier to work with. So I need to get rid of the 10x first. So to get rid of 10x here, I'm going to subtract 10x off both sides. So do that in a different color. Let's do it in red. So minus 10x here off both sides. And what I'm going to get here then is x squared. 7x minus 10x would give me minus 3x. We've got minus 30. And that is less than or equal to minus 2. So from here now, I need to get rid of the minus 2 on the right hand side. So in fact, let me do it in red again, just to keep it consistent. To get rid of minus 2 here, we need to add 2 to both sides. So plus 2 and plus 2 here. So what would we get in this case then? Well, I'd get x squared minus 3x. So x squared minus 3x. And then minus 30 plus 2, that would give us minus 28 there. And that is less than or equal to 0 because minus 2 plus 2 gives us 0. So from here now, what I've got is a nice straightforward quadratic inequality here. So all I need to do now is try and factorize. If I factorize this quadratic here, what would we get? We get x minus 7 and x plus 4. And this is less than or equal to 0. Okay. So from here, we now need to identify the critical values. So we're going to get x equals 7. And we're going to get x equals minus 4. So once we have the critical values here, remember we now draw a sketch. If I draw my sketch here over to the left, this is my y-axis here. This is my x-axis. So minus 4, that would be say there, and 7 say here. 7 and minus 4. So altogether then we're going to get a U-shaped parabola here, and it cuts through at minus 28. So altogether it's going to look, say, something like that. Okay, it's not perfect, but we've got that U-shaped parabola there. So now, where is this below the x-axis? So again, if I use a different color here to highlight this, let's do it in orange. Then it's below the x-axis between minus 4 here, including minus 4, and 7, and we're also including 7. So for my solution then, for x here, we are between minus 4, inclusive, and same then for 7. Okay. And there we have it. So that gives us the solution there to the very last question, question 3. That brings us to the end of this video on trickier examples for solving quadratic inequalities.